One of my favorite games as a kid was Battleship. The goal of the game was you were given 5 different boats and you could place them at various places on the map. And your goal was to sink your opponent's boats before they were able to sink yours. On your game board, you were given something that looked like this: A through J and 1 through 10, and you could make guesses on things like E2, which would go to E and then 2. And you would either hit or miss, and you would do this until you sunk your opponent's boats. However, the game is extremely limited by the fact that you can only have 10 spaces and 10 spaces. And if we in math were able to create a bigger and better grid, maybe we could do Battleship, but in real life. And I'm glad you asked, because that's exactly what we're going to do today. It's Battleship, but better. It's called the Cartesian coordinate plane, but most people are just going to call it the coordinate plane, or the grid, which is something like this, which you've probably seen at various places in your life before. Now, the grid has a few very important pieces of vocabulary that we need to master right away. The first one is called the x-axis. Well, there are 2 axes like this. We have the x and the y-axis. The x-axis is right here, the one that is horizontal, and the y-axis is right here. It is vertical. The way that I remember it is if I make a Y with my body right now, straight up and down is the Y-axis. And if I make an X with my body, I kind of can't do both at the same time, but I end up going mostly horizontal, and that makes it the X-axis. Now, the origin is just the center of the Cartesian coordinate plane. It's right here. The origin, or the point 0, 0. It's the origin. Now, the last piece of vocabulary are the fact that we have 4 quadrants. Okay, quad means 4. That means there are 4 corners of our grid. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In the top right, we have quadrant 1, and they are written in Roman numerals. And you're going to ask me, why are they written in Roman numerals? And I don't know. They have always been written in Roman numerals. Not exactly sure why. Quadrant 1. Quadrant 2 is up here. Quadrant 3 is down and to the left. And finally, quadrant 4 is down and to the right. Now, of these quadrants, I always want you to remember quadrant 1 right away. And the reason why quadrant 1 is important is that this only has positive numbers in it. Only positives in quadrant 1. Therefore, it's the quadrant that most people prefer to work in. From there, you move counterclockwise to quadrants 2, 3, and 4. If you show this vocabulary list to your teacher right now, you are entitled to some free classroom currency. Before we start graphing, there's a very small piece of information that is vitally important, so we need to listen close. All quadrants are given in x, y. Or, for example, we could do 3, -2 would be an example of a quadrant. But we have to figure out where is 3, -2. Well, we are always going over and then up and down. So in our problem, we would start at the origin, which is the center, and we are going to go over 3. Well, positive numbers are to the right, negative numbers are to the left on every number line we work with. Therefore, we're going to go to the right 3. 1, 2, 3. And then we're going to go down, because this is a negative, and we're going to go down 2. So our final point is right there. That is the point 3, -2. Now, if you notice, I put a point here just to show you. You never actually want to hit that actual point and mark it down. So you're going to go 3 to the right and down 2. Now, the way I try to remind myself to go over before you go up and down is twofold. One is you think of a hurdler. If there's a hurdle out in front of you, you have to run to the hurdle first, and then you jump over the hurdle. So you have to run over before you jump up. Over before up. The other way to think of it is if you are reading a book, you have to read across the page first, and then you work your way down the page. So, over before up or down. Okay? Let's do a few examples together. So, we're going to graph on the coordinate plane. I gave you 3 points on the left. I also gave you 3 other points on the right. Our goal is to take these points and graph them over here, and then take these points and write them to the right. So point A, we're going to start with first. Okay? So we always start at the origin, and I want to go over before up or down, okay? Well, I need to go over -3. Well, negative is left, so I'm going to go 1, 2, 3 to the left. And I want to go 5. Well, 5 is positive, so I'm going to go up. 1, 2, 3, 4, 5. That puts point A right here. -3 over and 5 up. Point B, we need to go 4 over and then 2 down because that is a negative. So I start here, and I'm going to go 1, 2, 3, 4 in the positive direction, which is to the right, and I'm going to go 2 down. Puts me right there. And then finally point C, we start at the origin, and I want to go over 0. Well, I'm right here, and going over 0 means I stay right there. And then I need to go 8 up because it is a positive 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. And I land on point C there, but I put it in the wrong color. Point C. So 1, 2, 3, 4, 5, 6, 7, 8. Point C. So I have now taken these by going over and then up or down, and I've graphed them on the left. But let's do the reverse now, okay? Let's take the point that's already graphed, point D, and I have to write it as an ordered pair. Well, to start, I always want to write my 2 parentheses with my comma to remind me that it is 2 separate points or location, or 2 separate points to make one location. So, point D, from the origin, I went left, therefore my over is a negative, and I went left 1, 2. So negative 2. That puts me right here. Now I know that I go down and not up, which makes this a negative, and I go down 1, 2, 3, 4, 5, 6, 7, down 7. So left 2, down 7. Point E is over here. So once again, starting from the origin, I'm going left. So it's a negative. And I'm going left 1, 2, 3, 4, 5, 6, 7. But then I'm going up, making the up, down a positive. So 1, 2, 3, 4, 5 for point E. Then finally, last but not least, is point F. Now on point F, I'm going left, so negative, and I'm going left 1, 2, 3, 4, making this negative 4, comma, and I don't go up or down at all. Therefore, my up-down point is 0. So in front of us, we have a very small coordinate plane that I have hidden 2 boats on, and our goal is to find the boats by inserting coordinate pairs, okay? So, I'm going to just pick a coordinate pair right away. Let's go 2 over and 2 up. That would be 2 over and 2 up like this. I hit fire. That's a miss. There's only water there. So now let's go 1 over and 2 up. Oops, I got to insert here. 1 over and 2 up. Still only water. Well, let's go down this time. So let's go 2 over and 1 up, just like this. Apparently, Mr. Schmidt's not very good at this game. We're going to go 1 over, 1 up. Oh, I found part of a boat. Now, if I'm looking, it looks like the boat has to be below this point. That would be right here. Well, this point right here is 1 over and 0 up. Well, I know that I go over before I go up. So it's 1 over and then 0 up. There it is. I got 1 left. So I have to go below this point. So that's 1 over. And then it's going to be 1 down. Well, down is going to be negative. And there is our final boat. Our final part of that boat. So now I got to try to find the other boat. So I'm going to make a few guesses here. Oh, look at that. Well, here's how I'm going to end this video. That boat right there has only 2 spaces. So it has to be to the right of the space that we just clicked. -2, +2. What do you think the last space needs to be?